still on the theme of inequations, inequalities, we're talking about placing inequations on the number line, but how about on the number plane? In other words, regions. So in order to draw a region, we have to sketch the curve. The curve basically is the boundary of the inequation. If it's just less than or greater than, we use a dotted line to indicate the boundary is not included in my solution. So if it's an equal to as well, then we use a solid line indicating the boundary is included in the solution. Now the points of intersection. We should circle the point of intersection and leave it unshaded if it's not included. Now, the only time it will be included is if two solid lines meet, because it has to satisfy both of the boundaries. So if you've got a dotted line coming in and meeting a solid line, then that point would not be included in both regions. So circle. Then to work out where we are, just test a point. Similar to what we did with the number line. Just grab a point, see if it works. Okay, let's do a very easy one. Y is less than x plus 3, so the boundary is the line y equals x plus 3, dotted. So I'm either going to be above this line or below this line. The 0, 0 has got to be the easiest point, I guess, to substitute in. So let's sub that in. 0 is less than 3. Yes, it is. So therefore, 0, 0 is included in our shaded area. We shade below the line. Doesn't have to be lines, of course. Circle. X squared plus y squared greater than or equal to 9. So our boundary is the circle and radius 3. In this case, we're either inside the circle or outside the circle. So again, 0, 0. Let's put it in and see what happens. We get 0 is greater than or equal to 9. No, it's not. So therefore, we must be on the outside of the circle. Oh, this is an interesting one. Y is less than the square root of 4 minus x squared. So the boundary is the semicircle, y equals the square root of 4 minus x squared. Now, we haven't really broken up this shape now into two regions. Let's just test a point. 0, 0. 0 is less than 2. Yes, it is. That would be the common mistake, just leaving it like that. But that's not the final solution. That's the final solution. Okay, a couple of things to point out. Why is it the final solution? Because the domain for this function is x is in between minus 2 and 2. Now, below the x-axis for this one, if I substitute a number into the square root of 4 minus x squared, I'm going to end up with a positive number. So therefore, below the x-axis, I must always be less than, because it'll be negative. Pick any point underneath if you don't believe me. Let's go for naught. Oh, give me a number. -7. Okay, -7. Sub it in. Square root of 4 minus naught squared. Square root of 4 is 2. Is -7 less than 2? Yes, it is. So with these root ones, we sort of get like a keyhole effect where we extend the domain down or up, depending on whether we're doing less than or greater than. The other interesting thing is you'll notice that it's not dotted below. Because again, on the actual boundary, we'll satisfy the inequality. So if I pick a point, let's say x is -2, y is, pick a y value.
-5.
Negative which?
-5.
Okay, so -2, -5, let's sub it in. Square root of 4 minus -2 squared, 4 minus 4 is 0, is -5 less than 0? Yes, it is. So that part of the boundary is actually solid. So technically, there's something else I should have had on this. Where? At -2 and 2, where the dotted line meets the solid line.
Would it be an open circle?
Well, let's see if it works. Let's try x equals 2, y equals 0. If x equals 2, I get the square root of 4 minus 2 squared, which is 4 minus 4, which is 0. Is 0 less than 0? So it's not included. So it should have been an open circle at both 2 and negative 2. So a very interesting inequality, that one. Okay, intersection of 2. So I've got y is greater than or equal to x squared. So the boundary is the parabola y equals x squared. Let's test a point. I can't use 0, 0 this time because it's on the curve, so it's not going to help me. So I picked 0, 1. Basically, I need to know the position of the point I'm testing. I know 0, 1 is definitely inside this parabola. So let's just test it. 0 is less than or equal to 1. Yes, it is. I know I'm on the inside of the parabola, but I'm not going to shade yet. What I'm going to do is I'm just going to mark some points so I know, righto, I'm on the inside of this parabola. Now the line. Y is less than or equal to 3x plus 4. So I'll draw that line in. Again, it is a solid line. I can use 0, 0 for that one. It's probably a good idea to find the points of intersection. So we solve them simultaneously. X squared equals 3x plus 4. We end up with negative 1 and 4. So there's our points of intersection. Okay, let's test a point. 0, 0. 0 is less than or equal to 4. Yes, it is. So I know I'm below the line. So I guess the question I'm now saying is, where do I have both red and blue crosses? That's the region I'm interested in. And so it's that little piece inside there. So that's my region.